Alrighty, so now we've dealt with one sample, we've looked at types of errors that could occur. Now we're going to look at two samples. And when we use two samples, we're typically looking for the difference in the parameters. So here we're going to be looking at a two sample z interval for the difference of proportions. And we can see here that when data comes from two independent random samples, from either random samples or a randomized group, we're going to use the statistic p hat 1 minus p hat 2. And this will be our best guess for the estimates of P1 minus P2. Now, we're still going to use the panic model, and we're still going to use state plan do conclude. And so we start with the parameter, which we're going to look at P1 is the true population proportion of group 1, P2, the true population proportion of group 2. Next up, our assumptions stay the same. We need some element of randomness, whether it's a random experiment or a random sample. We need independence within each sample by verifying the 10% condition. And then we need independence between the samples. And this can be stated as either two independent SRSs or some element of separation between the two population groups. And then lastly, we're going to check the normality condition by ensuring that our sample is large enough to use a normal approximation. And we'll check this by doing n times p hat 1, n times the complement of p hat 1, n2 times p hat 2, and then n2 times the complement of p hat 2. And I'll show you some examples of what this looks like. But we are basically checking the conditions within each population, each sample from that population. The only added condition is that independence between samples. And again, are there different gender identities? Was the data collected from two separate places? Some element that tells us they should be independent. Now, if these conditions are met, we are going to use a two-sample z interval for the difference of proportions. So again, how many samples, quantitative or categorical, interval or test, and then what is it for? And we will get this value here. And again, this just comes to us from the statistic plus or minus the critical value times the standard error. And I know it's a standard error because notice that these hats tell me this is the sample proportion. And then the statistic we previously mentioned that p hat 1 minus p hat 2 will be the best guess for p1 minus p2. Now I'll show you how to do this in the calculator, but if you are asked to do this by hand, that's totally possible. Most times this shows up on the multiple choice section, and it's just asking you to recognize the formula in the problem. Now this could be fractions or decimals, so you need to be prepared to do both. And then lastly, our interpretation does not change. We are C% confident, blank to blank captures, yada yada. Now there are some new ones. Remember, the confidence level is still here. And what's different now is that since I'm creating this interval, if 0 is included in the interval, the only way for the difference to equal 0 is if there is no difference, meaning that the two values are at some point equal. Now, if 0 is not in the interval, this would indicate that there is a difference, and depending on if it's a positive or a negative difference, that'll tell us which sample proportion was greater. And that would lead us to believe that maybe that population proportion might be greater. So let's take a look here at an example, and we're going to look at college residency. Are students who identify as female or students who identify as male more likely to attend college outside of their home state? Two independent random samples of both groups for college-bound high school seniors were taken in the Dallas-Fort Worth metropolitan area in September following their high school graduations. The students in the sample were contacted to see if they were attending college in Texas or outside of Texas. We have the following. So again, there was no order stated for us, so we're just going to go with P1 is female and P2 is male because that's the order presented. And notice this is a two-way table. And if I add up the total female group, I get 450 females. And if I add up the total male student group, I get 306 males. So we are asked to construct the 95% confidence interval for the difference in population proportions, as well as interpreting it. So let's state the parameter. We want to estimate P1 minus P2 with 95% confidence, where P1 is the true proportion of female students who would attend college outside of Texas, and P2 is the true proportion of male students who would attend college outside of Texas. Now, these little dashes that I'm making are just shorthand for the reader to know that, like, oh, this is the same, here's a difference, same. So you can use that cheat sheet in class. Now, AP exam, they would fully expect you to write out these parameters, and it's okay, just an extra sentence. Now, let's look at our plan. We need to verify the conditions, and we need to name the test, assuming the conditions are met. Well, in my plan here, my sample proportion for p hat 1 would be the successes of group 1 over the total, so 121 out of 450. P hat 2 would be the successes out of the total sample for the male group, 94 out of 306. So I get this difference of proportions here. Now, my first two conditions are met slightly because I'm looking for randomness and I'm looking for independence between the samples. Well, I was told that two independent random samples of 450 females and 306 males were used. Next up, I was told that we can believe that these populations are relatively large. So I can believe that 405 Texas female students is less than or equal to 10% of all female students in Texas. I can assume that 300 Texas male students is going to be less than or equal to 10% of all male students in Texas. And then lastly, what I'm going to do here is I'm going to check the large counts condition. And I'm going to do so by checking the successes and failures within each group. Sorry, I don't know why this is giving me some heartache here. Here we go. Ay, caramba. All right. One moment for some technical difficulties. All right, so slightly zoomed out here. Sorry about that. But the successes in the female group are 121 and the failures are 329. And I can see this from the count of values. So I'm not going to show my math here because I can see the counts in the table. And then I do the same for the male group. And I can say that the normal model is appropriate by the large counts condition. Now, since our conditions are met, we are going to use a two-sample z-interval for the difference of proportions. Now, if I were to use this formula here, I should get this approximate interval. And I'm 95% confident that the interval from negative 10.4% to 2.8% captures the true difference in proportions between female and male students who would attend college outside of Texas. Now, how did I do this? Well, we are going to have to refer to the calculator. I could do this by hand, but I'm just going to show you what you're going to do here. All right, so sorry about all the clicking here. So let's go. You are going to start off in the scratch pad. So calculate. We're going to go to menu, a statistics class, confidence intervals. And at first, it is easy to think it's a two-sample z-interval, but we're looking at proportions. So we're going to do the two-prop z-interval. Now we know that the proper name is a two-sample z-interval for the difference of proportions. But I'm just going to take my data and I'm going to enter it. So from the data, the successes in group 1 were 121 out of 450. The successes in group 2 were 94 out of 306. And I believe we wanted the 95% confidence interval. Well, we click OK, and you'll notice that we get the same exact result. So negative 10.4 to 2.76, which is about 2.8. So we got those results just from using the calculator. And since we properly named the test, we can just give the interval. Now, based on the constructed interval, do you believe that the data from random samples indicates that there is a difference in the proportions? Well, let's look here. If there is a difference, either the interval is all positive, which indicates the female had a higher proportion, or the difference is completely negative, which would indicate that the males had a higher proportion. Well, here we see that we include both negative and positive values. 0 is in there, so I would say something like, since 0% is included within the interval, there is no difference in the proportions of students who identify as male and students who identify as female that would attend a college outside of Texas. I believe there's no difference because 0 is in there, and 0 can only be in there if there is no difference. So that's the idea of how you'd answer that. So go ahead and pause the video now, take a look at example 2 and example 3, and we'll come back together and review those. Now, when we looked at example 2 with the birth rates, no random assignment was used, so we cannot infer cause and effect in the described study between births to unmarried couples and residency status. It's a random sample, so I can only show correlation, not causation. Then next up, we look at the interval here. Well, no, since 0% is included within the constructed interval, we cannot claim that the proportions are different because the only way 0 would be in there is if they are the same. And then lastly, example 3 is exactly what I'm talking about in terms of what you'd expect to see on the AP exam. So when we look here, notice that I'm just finding the different proportions and then I'm just filling in the formula. So I'm not actually calculating, I'm just looking at what I'd expect it to be. Now, it's a multiple choice question, so we can use a process of elimination. I noticed that it's 99%, so if I were to look at my Z table, 99% corresponds to about 2.576. So that's already going to take out answer choices A, B, and D. So just knowing some basics about the confidence interval is going to help out with these problems. So I'm torn between C and E, and plot twist, we haven't even learned anything about E yet, so that just leaves me with choice C. And if I were to calculate this out, I would get the same confidence interval as stated here by the formula. Now, I do want to note here that if you were to do this in the calculator, you would just have to use the formula, because note that it gave us the proportions. It didn't give us the exact success number. Now, I could find the success number by multiplying the sample size by the proportion, but we'll do some more examples with that later. But for now, that's going to conclude our two-sample z-interval for the difference of proportions. And in the next lesson, we'll wrap up our inference for proportions unit by looking at the hypothesis test for the difference of proportions. So stay tuned.